Hello, I'm David Holmes. I'm the inventor of the LightLead, and I thought I'd take some time to show you guys a few things about the LightLead and why you might want one and what the difference is between a copper cable. So firstly, I've got here a guitar, I've got a regular cable, and it goes through a copper cable, and then we're plugged into an oscilloscope here. That way you'll be able to see the waveforms and stuff. So first of all, let's start with the copper cable. So I've got one plugged in here. Just a regular copper cable there, and going through into the oscilloscope, and then I shall strum the guitar, and then you can see the guitar waveform, nice and healthy, and that's the guitar seeing a 50 megohm input impedance there, so it's a nice healthy signal from the guitar. So let's plug in a LightLead now, and then so we plugged into the LightLead. It goes through our optical patented analog system, and then it comes up to the oscilloscope, and then I'll do the same thing. I'll strum the guitar, and you can see nice healthy waveform there too. Great. Okay, so now let's plug this guitar into a desk, but we don't have a desk here. So what I'm going to do is, I've got a little resistor here that's 10k, which is roughly what the input impedance of a desk is. And if we bridge this across the output of the guitar, that has the same effect as plugging it into a desk. So I'm going to plug this across the regular guitar cable first, and then we're going to plug in the regular cable. So we're going through the regular cable now. We've got a 10k across the output of the cable as if it's going into a desk, and then we're going into the oscilloscope, and then I'll just play this here. And you'll see there that the signal is reduced. And what I'm going to do is, while I'm playing, I'm going to unplug the 10k resistor so you can see the difference. So this is the signal now, and then I'm going to put the 10k back on as I'm strumming, and there you go. See that signal drops right down. That's it unplugged, and then that's it plugged in again. So that's all I'm doing. Okay, let's try that same thing again now with a LightLead. So we're going to plug in a LightLead, and I'll just show you the signal from the LightLead again. So there it is, and then we're going to plug in this 10k resistor as if we plugged it straight into a desk. Go in there, and then we'll show you the signal. The signal is exactly the same as it was, and I can show you that in more detail if I unplug the 10k resistor and then play. This is without the resistor, and then if I put it on, that's with, that's without, that's with, that's without. You can see there's absolutely no difference in the output from a LightLead. Why is that? It's because the two ends of the LightLead aren't connected. They're connected through an optical system, not an electrical circuit. The guitar signal stops here as an electrical signal. So all this guitar sees is a 1 megohm impedance here. It's then transferred through the optical system via a patented optical analog system, and then it comes out of this end, and it's got about a 1k output drive on it. So that means that it doesn't matter what you plug the output of the LightLead into, it cannot affect the way the guitar signal is affected by different input impedances. So you plug it into a desk, it's the same signal. Plug it into a foot pedal, it's the same signal. Plug it into an amp, guitar amp, it's the same signal every time, consistently. With a copper cable, different inputs will change the way your guitar sounds, different cables, different lengths of cables, because of capacitance build up and everything else. So we've removed all that by using an optical system. There's no capacitance, there's no loading on the guitar. It's a consistent impedance that the guitar sees all the time. And of course, you're electrically isolated, so you won't be getting any shocks off of the microphones or any ground loops that you'd normally get. So that's why we did that. Now let me just show you one more thing, and that is to show you that this oscilloscope is calibrated on each channel, and they've not been modified in any way. And to do that, I've got a little signal generator here. So what I'm going to do is, down here is where the cables were plugged in, and I'm going to take the channel outputs that was on the regular cable and plug it into our signal generator, and you'll see on the screen what is a waveform, and I'm going to take the same thing from our LightLead, which goes over to this channel, and I'll plug that in, and you'll see here that it's another cable there. Let's plug that into this one. I've got my wires all crossed here, hold on. This one onto this. There we go. And then this earth onto this earth. There we go. Now you can see there looks like there's one waveform, but there's two channels here, and all I did was made sure that each channel was reading the same input level, and then just matched them so that when I turn this off there's a flat line. But there is two channels, so these inputs are calibrated so that the inputs you see are the same voltage signals. I haven't boosted anything or changed any gain. So there you go. I hope that was informative. If you've got any questions or anything, you can always email me, dave@iconicsound.com. I hope this has answered some questions. I'm sure it will generate even more questions, but I hope you like it, and yeah, get in touch. It'd be great to speak to you. Thanks very much for watching.